Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to solve one example about flash unit where we can find the compositions and the flow rates of the gas and liquid at equilibrium. Let's begin with the question. Question says, calculate the compositions and quantities of the gas and liquid molar flow rate in pound mole per hour when 100 pound mole per hour of the following non-ideal gas is brought to equilibrium at 150 degree Fahrenheit and 200 psi A. And we have the component propane, N-butane, N-pentane, and we have the compositions of the feed. So let's make feeling of this question by drawing it. Firstly, we draw the flash unit. Here is the feed. Here is the gas stream. And here is the liquid stream. Here it will be Ng and Yi. Here N liquid and Xi. And this is the quantities where we want to, which we want to find it. Here we have Zn, and we have the compositions of each component. For the propane, C3, we have 0.61. For N-pentane, NC4, we have 0.28. For N-butane, sorry for this one, and here for N-pentane we have 0.11. And the pressure is 200 psia. The temperature is 150 Fahrenheit. Okay. In order to solve this question, we need to know the main equation for solving it. So we have sigma y equal sigma zi over 1 plus n dash l 1 over k minus 1. And this one is nl over n total. We have n total equal to 100 pound mole per hour. So in order to solve this question, we need to find the K values. How to find the K values? Of course, we have one picture for the K value. So here is the pressure in psia, and here is the temperature in degree Fahrenheit. We have 150 degree Fahrenheit, and we have 200 psia. Just draw a line across these lines, and we find the K value for each component. Let's solve the question now. We said that we have 0.61 here, 0.28, and 0.11. The K values from that graph, we get it 1.549 for propane, for butane 0.593, and for N-butane 0.237. Now we need to assume NL dash because we don't have it. So firstly we assume it 0.5 and we try to solve the question. When we assume it 0.5, we will just apply the equation, which is Zi, which is 0.61 for propane. Then we have 1 plus the value that assume it 0.5, that will give us 1 over the K 1.549 minus 1, and this will equal to 0.741. Then we complete for each component, and we get 0.208 for the C4 and 0.0421. If we add them up, we will get 0.991. So we need to have another value because we want it to be near the value which is 1. So we assume another value for NL which is 0.6, and we recalculate the compositions again. We get 0.7747 here. For the NC4, 0.1983. Of course, we use the same formula for each one to get this value, and here 0.0375. If we add them up, we will have 1.01. Now we want to, in order to stop the calculation, we want it to 1.00, not 01. So we will have now the interpolation. How we do the interpolation? To get the n dash value, we have 0.5. The total compositions was 0.991. If we when we do for 0.6, we get 1.01. Now we have this value in order to get it 1. So by interpolation, this one minus this one over this one minus this one equal to this one minus this one over this one minus this one. So 0.5 minus x over 0.5 minus 0.6 equal 0.991 minus 1 over 0.991 minus 1.01. So we get x equal to 0.547, and this one will be our n dash L. When we recalculate the compositions again, we found that for C3, 0.7567, for C4, 0.2035, for the last one, 0.0398, and our sigma y here is equal to 1.002, which is equal to 1, approximately is 1. Now, in order to find, we already found sigma y. Now we need to find sigma x. Sigma x equal is equal. We know that the formula is y equal x k. So x equal y over k. We have this one for each component. We have this one for each component. So we can find x for each component. X for C3, sorry, is equal to 0.4885. For NC4 is equal to 0.3431. For the last one, which is NC5, equal to 0.1679. If we add them up, sigma xi equal 0.9995, which is almost 1. Now we find the compositions. If we want to find the flow rates for each one, we just do the we just back to this diagram, and we do the component balance. How to do component balance? We have Zn, we choose the first one, which is C3, multiply by 0.61 equal Ng multiply by the composition which we find it, which is 0.7567 plus NL multiply by the composition of the first component, which is 0.4885. NL equal to Zn minus Ng. Substitute this one in the and we have Zn, which is equal to 100 pound mole per hour. We just substitute this one, Zn, NL equal to Zn, which is 100 minus Ng. Substitute this one here, and we will get the molar flow rate for each one. Thank you for listening, and I hope that you understand the question.